Section 4, in Section 4 we didn't finish the problem that had the reciprocal of x, y, and z as part of the system, and so I thought I would do one example here in case you want to try your homework about this. So I've got a system written right here. It's the system with these three equations, and the trick that we used was that you could turn this into a system more like we had been solving by letting u be 1 over x, v be 1 over y, and w be 1 over z. And down here it shows why something like 2 over x would be the same as 2 times u. You could write it as 2 over 1 times 1 over x. 2 over 1 is 2, and 1 over x is equal to u. So when you replace the x's with the 1 over x's with u, the 1 over y's with v, and the 1 over z's with w, you get a system that looks like this. And we can solve this in the usual way. Here I've decided to get rid of the w's, so adding row 2 and row 3 gets rid of the w's, and doubling row 2 and adding it to, doubling row 3 and adding it to doubling row 3 and adding it to row 1 also gets rid of the w's, and so we get two equations. 3u minus 4v is negative 6, 3u minus v equals 3. We've got two equations and only two variables, so we can solve that. I could say cancel out the u's by multiplying the first equation by negative 1 and adding, the elimination method in other words. I would get v equals 3. Once I know that v equals 3, I could substitute it into one of my other equations, like this one, and if I solve I get u equals 2. And then once I know that u equals 2, I could take an equation from the first page, like u minus v minus w equals 0, put in values for u and v, and solve for w. I got w equals negative 1. But the problem originally started with x, y, and z as the variables, so I need to put 1 over x back in place of u. So I'm looking over here right now, and 1 over x means the reciprocal, so if I take the reciprocal of both sides, I get x equals 1/2. If I do the same thing with v equals 3, I get y equals 1/3. With w, the reciprocal of negative 1 is still negative 1, so z is equal to negative 1. And so the solution to this system is 1/2, 1/3, negative 1. I know I had all the work shown ahead of time, so if you need to, you could play this again and hit pause at key points so that you could copy down the work if you wanted to.